All right, so take as an example, 3y minus 5 equals negative y minus 17. We want to get the y on one side, right? So we would put a little, if you're in Algebra 1, you might write plus y, and that's really good. I'm sure your work understand that. I think we're at a stage now, from this point forward, where we could do that probably in our heads. Most of you could, I think. And it actually makes it a little cleaner and a little easier. You're going to notice, you're just going to see this step. And, you know, when you get into Algebra 2 next year, your teacher's going to expect that you can follow what just happened there, right? I think we can. I think we're there. And what we're going to add in here is the justification step. How did I end up with 4y over here? What did I do? I added y to each side, and what property do you think that is based on that list of properties on the top? Yeah, addition property of equality. So you would write on here, you know, addition property of equality. We can maybe abbreviate it, but addition property of equality. And it's not just addition, it's addition property of equality because what we did to the right-hand side, we also did to the left, right? We added y to the right-hand side to make this be a 0, leaving only negative 17, and then we did the same thing to the other side. Next step, what would my next line, how would it read, do you think? Plus 5 on both sides, but we're going to not write the little plus 5 underneath. We're going to just say 4y equals negative 12. And what's the property that I just used to do that? The same thing again, right? It was just an addition of the 5. So addition property of equality again. And then final step, what do you do next? It's the division. We're dividing each side by 4, so we get y equals negative 3. What's the reason behind it? Division property of equality. And so in an effort to not just drive you nuts on this, because you're doing something that's fairly easy for you guys at this stage, I think I just follow the instructions as you're doing both the, there's some practice problems on the next page. I think I asked you to do this with just 2 of them. You get to pick a couple as opposed to all of them, but I give you more problems than just 2, so I want you to practice. We'll go through algebra, so a little algebra review here. All right, let's try the next one. What's the first step? You're explaining, multiply it through. What do we call that? You could do division property, but I wouldn't recommend that. Distributive property. So we would write down 2r minus 6 equals r minus 4. And the reason behind that is distributive properties. You can abbreviate that, DIST prop, distributive property. That's the reason. So we're really building that. You know, if you've seen any, I could take that. But I don't know. I'm not hearing too many groans out there, so you don't know. I don't know if you've done any proofs or geometric proofs, but that's what we're headed to, is a 2-table geometric proof where you have the reason, or the statements would be in red, and the reasons justifying each statement in green there. So here we go. Next step. What would the next step be? It could be. You could. What were you thinking you would add each side? Add 6 each side. Sure, you could do that. Yeah. Okay, subtraction. Yeah. So you're subtracting r. So either one would be fine. It's kind of a choose your own adventure deal here. You guys can get, but whatever step you do, you need to then write a justification here, and it won't necessarily match mine. Just based on what I would probably tell my Algebra 1 students, I would probably tell them to deal with the variable first, get it on one side first. So I might go with the subtraction property of the r. So I'd have r minus 6 equals negative 4, and we would say that is subtraction property of equality. Okay, and then the next step, I would then probably add the 6 over, so we have r equals 2, and that would be addition property of equality. because we're doing it to each side. If I just say addition, it's like, well, addition, that could be combining like terms on one side or the other. So I'm noting the entire property. I'm saying that I am adding the same thing to each side because I'm allowed to do that myself. Yeah.
Actually, never. It doesn't have to.
Okay. Yeah.
Do we have to do that in 2 steps? Because I did it.
Okay, what did you do in 2 steps?
I just like put the subtraction like I
Okay, no, you need to list each one. There are different properties and different steps. But what I am encouraging you to do is to not put the little plus, the +6 underneath it. We should be able to. Yeah, it's cool. We should be able to move beyond that. I mean, if you need to do that, that's fine. But you would write, like if I do the little +6 here, in blue, say that right here, +6, +6, totally fine. If you need to see it, you're visual, you need to see that lined up, fine. But you're going to write the property just once with the conclusion of what happens after you add 6 each side. And that's what you're going to see, like in the textbook, they're going to have you try some problems, and it's going to be the conclusion of the operation where you write the property. You'll see what I mean later. There's some fill in the blank. They're prepping you for 2-column proofs in geometry. All right, next one. We've got 2r minus 4 equals 3r minus 12. You recognize the property? Yeah, and in this case, Eva, I did it same line, both sides. So we're just going to do it all at once. Distributive property. And then it's kind of your choice. If I wanted to, I could subtract 2r from each side and then keep a positive number in front of r. It would look like this. -4 equals r minus 12. So you see what I did? I subtracted 2r here and 2r here, just for the purpose of keeping a coefficient that's positive in front of r. And that would be which property here? Subtraction. And then I might add the 12 over. So I have r equals 8, and that would be addition property. Yeah. So we've gotten away from this in Algebra 1 a little bit. You could probably see why. I mean, this is just like may have overwhelmed you. Some of you are going, why are we doing this? It's ruining equation solving for me. It's okay. But, yes. Yeah. It's a little worse than sugar computer. But it's just demonstrating that there's a justification that goes on. Yeah, they want to know that you know that. Yeah. And you do, but you're explaining it and showing the justification here in each step. So here, boy, this one, I just gave an Algebra 1 test. This was like one of the most missed problems. So let's see if we can do it. What would you do first? Yeah.
Multiply both sides by 3.
You could, and some of them did that. But here's, don't write this down. Here's what they did. Ooh, well, I don't think I had anybody do that, but they did try to multiply 3 by 3. Here's the problem. Don't write this down. This is kind of interesting. They multiplied this by 3 and this by 3. What's the problem with that? Yeah,
They didn't get the -1.
they didn't. Yeah, and so I think of all. Yeah. Anyways, this was one of the most missed problems on the first test that I did. Yeah. So I don't know that I would suggest that unless you're a little more mature like you guys are and you can see that. This would work, but I would do something different first. Does anybody have an idea of what you might want to do first? Yeah, I would take care of that first. Add the 1 first. It's probably safer. So we can add 1. So we got 2/3 x equals 8, and that is the addition property. It's because we're adding 1 to get rid of the -1 here. Okay. So addition property. And then you could divide by 2 and then multiply by 3, but maybe a little better, more efficient way to do this. Yeah. Yeah, multiply by the reciprocal. So we could And since we're having to write down the justification, let's be efficient, right? So how about multiply each side by 3 over 2? And you might need to see that step. Maybe we'll show that in here, what it looks like. So it would look like this. We have 3 over 2 times 2/3 x equals 8 times 3 over 2. So we're multiplying by 3 over 2. And so the purpose of that is that this equals what? X, just X. And then we've got to explain, or in Algebra 1, we usually end up explaining, well, how do you multiply a fraction times a whole number? Right? You handle it. Yeah, a lot of you have been told, sure, that'll work. You don't have to, but you could put it helps students sometimes to think of this as 8 over 1 times 3 over 2, and then we remember, oh yeah, I just multiply straight across. Maybe cancel first, and then multiply straight across, but multiply straight across. 24 over 2 reduces to 12, yeah, so x equals 12. Or canceling first, and I get to say, cancel right here. So 4 times 3 is also 12. Yes.
I got the same answer, but
Awesome. What did you do?
I added the 1 and then I times both sides.
Times both
Then I
sides.
divided the 2.
Right. So what did we do by multiplying by 3 over 2? Did we times it by 3 and divide by 2? Yeah. So multiplying by the reciprocal is just doing that, those 2 steps in one. And actually, a lot of my Algebra 1 students, they had one, I think it was like a 4/6 they had in front of their x. And a lot of them did that. They got it right. They multiplied by 6 first and then divided by 4. And a lot of them did better with that than trying to multiply by the reciprocal. So it seemed to make sense. And so that's
multiplying by fractions is usually harder.
Perhaps, yeah. They sure, yeah, made mistakes with it. They tend to, what I see them do a lot is multiply this 8 by the top and the bottom. It's like they distribute the 8. It doesn't work. It gives them, it gives them 24 over 16. And then they panic because then that's a fraction. And they're thinking that all of them should be whole numbers. But and most of them were, so they're right. Most of them were. But what's the green in here? What's the justification going to be? Yeah, just multiplication property of equality. So multiplication prop of equality. Of equality. Multiprop of equality. It'll be okay. And the time it took you to complain about it, you've written it. Right, so on the next page, you're going to try just some equation solving, and I'm going to let you choose 2 of them on there. You're going to justify the step. No, you need to do all of them.
Okay.
But you only need to justify the steps on 2 out of those 6. Good. Awesome. That'll work. That's okay.